Okay, so I want to talk about the addition polymerization process in regards to the leave insert engineering polymers section. Okay, so it's question 6 on the paper. So addition polymerization, what is it? So it's the adding together of a large number of monomers to form polymers. Okay, example polyethylene. So the example we always talk about in is always going to be polyethylene or polyethylene. Now, so polyethylene is made up of 4 hydrogen atoms and 2 carbon atoms. Okay, so C2H4. It's used to produce thermoplastics. Okay, so thermoplastics, polyethylene being an example, any other thermoplastics as well. So thermoplastics being materials that can be bent and reshaped to, once heat is applied, they can be bent and heated and reshaped to different shapes. Okay, now, so I have examples here. Okay, so here I have our structure. Okay, so the 2 black atoms here. Okay, so the black is going to represent carbon. Okay, and the white is going to be our hydrogen atoms. Okay, so I have 2 blacks and 4 hydrogens. Now, in our example here, we're told polyethylene is made up of 4 hydrogen atoms. Okay, so 1, 2, 3, 4, and 2 carbon atoms. Okay, so the black being carbon 1 and 2. Okay. Now, so the process at what actually happens here. Okay, so the ethylene monomer contains 4 hydrogen atoms and 2 carbon atoms, which are already after outlining it. Now, there is a double bond between the carbon atoms. Okay, so just if I turn this way, we see. I'll make it a little light there. Okay, so we see the 2 carbon atoms. In between the 2 black atoms, I have a double bond created. Okay, so this is my double bond here. We see between the carbon and the hydrogen atoms, there's only a single bond present between them. So the double bond present between the 2 carbon atoms. Now, what we want to do is we want to create. So at the minute, if I put this on a diagram, what I have here, I have 2 carbon atoms, okay, a double bond, okay, so I have my hydrogen, 2 carbon atoms, which are here, I have my double bond, I have my 4 hydrogen atoms, so 1, 2, 3, 4, which are represented by 1, 2, 3, 4, and these only have single bonds between them. Now, I want to create a long chain, I want to basically add all these carbon atoms together. I cannot add carbon atoms together if there's a double bond present. So I need some way in order to break down this double bond in order to add all these carbon atoms together. So what I'll do is I'm going to add a catalyst to the process. So here I have a catalyst, and I have this denoted by the R. Okay, so the R. A catalyst added to the process. And what this does is it's going to break up the double bond. Okay, so I'm going to bring this catalyst in. I'm going to this green atom here, or this green section here, is going to be my catalyst. Okay, so okay. Now, so what the catalyst is going to do catalyst contains what's known as an unpaired electron. Okay, so on its outer shell it contains an unpaired electron. Now, what this does is going to break down the double bond between the 2 carbon atoms. Okay, and join onto this catalyst. So here we have, I'm going to break down the double bond. So I'm breaking this, okay, double bond down here. And now what I'm left with a single bond between my carbon atoms. This double bond now is going to join on to that catalyst. Okay, so now this is what I'm left with. I'm left with a double bond. So essentially what I'm after doing, I'm after getting rid of this double bond here, okay, and adding in a single bond. Now I'm able to link all these carbon atoms together. Okay, so the next one we have is I want to link another one of these hydrogen, carbon, and hydrogen atoms. So here we have it here. Same as this, I have 2 hydrogens and a carbon, and I have a single bond. So this is the same as me coming along and adding this. Now because this double bond here that was originally added to this carbon is broken down, I can now connect this up to here. Okay, and that's another section of my atom complete. I can repeat this process then, so this will continue on, so I'll add another one on. Okay, and that's the same as me going another one here. And you can keep repeating that process then as much as we want. Okay, so there's millions and millions of these added up. So here we're starting to see the chains, like, so we have the carbon atoms, the black, and the hydrogen atoms in the white. Okay, now, so that's this step here. So what's happened here now? So once the double bond's broken down, other similar carbon atoms are linking up, and this is what we're getting at. Here. Okay. Finally, when the polymer is at the desired stage, I want to add another. I want to add something in order to stop the process. Okay. So what I essentially need to do is I need to add another catalyst, or in this case, it's going to be an inhibitor, in order to stop the process. Okay. So what I have here is I'm going to add another one of these. Okay, and now when that gap where it wants to join on to another carbon atom, because I want to initiate the process, instead of joining on to another carbon atom, I'm going to join it on to an inhibitor. Okay, and that's going to also contain an unpaired electron, and that stops the process. Okay, and then that's how the addition polymerization works. Okay, so initially we have a double bond between the carbon atoms. It's broken down. The catalyst is added. This allows similar carbon atoms to add together. Okay, so this is what we're doing here. This process repeats until I want to end the process. And at that stage, then I'm adding another similar inhibitor or free radical with an unpaired electron to the process. It's going to join on to that carbon atom and terminate the process. Okay. These addition polymerization, as I said, is used to produce thermoplastics, and the main example we talk about is polyethylene.